Welcome to Microsoft Build 2017. I'm Andrew Whitechapel. I'm a program manager on the App Platform and Tools team. And this is the second of two sessions on the new App Diagnostic APIs. So let's get started. We'll have a quick recap of what we looked at in the last session, which is the APIs themselves and one of the two main approaches for using these APIs, which was to build a general purpose tool. And then for the rest of the session, we'll look at the other use case, which is to build a targeted profiling app for your own app. So the APIs, the App Diagnostic Info class is the main class. It encapsulates things like the app info and app display info, which just give you package metadata, the name, the app user model ID, the package family name, and so on. And those are available in the Creators Edition right now. Then for the next release, we're adding the resource group info class. So each app diagnostic info will have one or more resource group infos. And this maps to the resource groups you might have in your manifest. And it encapsulates the more detailed memory and state and background task information that you're more interested in. Excuse me. And we've linked in the Process Diagnostic Info class, which is an existing class that we've modified so that they work together. The App Diagnostic Info and Process Diagnostic Info, you can get from one to the other in a cycle. And you might also use, particularly for the scenario where you're building support for your own app, you're building tools for your own app, you might also use the package APIs. And we'll see how it all fits together in a second. So I've got a sample app. This is an app I'm building that I'm going to ship in the store. And it's very, very simple, obviously, but I've deliberately made it so that it's got a few interesting components. It has a foreground part, but it also has a couple of different background tasks. It has a long-running background task, an audio playback task, and it has short-running tasks as well. It exposes some app services. So this is interesting because you'll get a different set of resource group infos. Potentially, you'll get a different number of processes involved. Those can come and go dynamically. And interesting things happen with your memory usage, for example, if you've got multiple components, and with your and what happens when the state of your app changes to what happens to those tasks when your state of the app changes. So let me switch to my demo machine, and I'll just demo this app. Let me just run it. Very simple app, background audio app service app. So it does some background audio playback. So that involves a long-running background task. This is an out-of-process background task. And it also has app services, which can be launched either from within the app or from outside the app. So it's a very simple app. Doesn't do anything terribly interesting. But let me stop that and come back. So it's interesting the choices that you have with the APIs to how to match what the target app is doing to the APIs that you use. So you can use the APIs for any app. If your target app is a UWP app, obviously that's the most useful. But even for a desktop bridge or a Win32 app, you can still use these APIs. But you'll get more information. So we saw in the last session when we looked at a very simple task manager that for Win32 apps, you get the process level information because that's the only thing the system knows about. You don't get additional package information because there isn't any additional package information. With desktop bridge apps, you will get additional package information because there is package information. But again, you won't get things like the use of shared commit because that's not tracked for desktop bridge apps. Or at least it's not tracked for the Win32 side of desktop bridge apps. And then if it's a full UWP, you'll have all of the information potentially available depending on what your app is doing. So if you do have background tasks, and depending on the type of background tasks, you'll have potentially more than one resource group. Remember, the resource group info class encapsulates all of the detailed metrics. So you may have more than one of those, which is why we always give you back a list. And usually in the list there's only one, but there might be more than one. There may be more than one process. There may be 0 processes if nothing's actually in memory at present. You can still get diagnostic info for apps before they start running. So you'll have 0 or more resource groups, 0 or more processes. You may or may not have background tasks, and those will come and go as the tasks themselves are activated and then completed. And obviously the energy quota only applies, or it's only enforced if you have background tasks. And if you have multiple different components which potentially are dynamically coming and going, then aggregating the usage becomes interesting. For example, if you want to, you'll get all the information for the memory usage for each component, for each resource group. You'll get separate memory usage data. And that's interesting in itself. But you also might want to track the total memory usage for the entire app, in which case obviously you'll have to drill down to the individual resource groups and keep a running total of the private commit and the shared commit and so on. Here's a summary of how you would use the APIs in this scenario. So unlike the task manager scenario, here's a case where we're building a tool that's profiling our own app. So we're going to use the request info for app async instead of request info. So there's a app diagnostic info, request info async method, which gets you all running UWPs. If you say request info for app, it obviously only gets just the one you're interested in and specified by its app user model ID, which you would know because this is in your manifest. And by default, it's some GUID-based string, but if you've reserved a name for your app in the store, then it will be a more meaningful name. So you can either request the info just for your app or just for your package. There's another version of the request info API that gets you the information for the package. And then once you've got the app diagnostic info for your app or your package, you can then start getting the resource groups. And as I say, there may be 0 or more. And for each resource group, you then start getting the detailed diagnostic info. So here's an example of the audio app service. This is the app I'm building and a profiling tool that I've built that will profile this app as it's running. So I'm going to close that and open my app profiler project. Well, let's run it. While it's building, let's look at the code. So I have a get packages button in the UI. When the user clicks this, I'm going to use the package manager APIs to get a list of all of the packages that are installed for this user, which is for the user that's running this app. So that's all deployed UWP and desktop bridge apps that are listed, that are deployed on this machine, including ones that have been installed from the store, as well as ones that have been deployed during development in Visual Studio, for example, or sideloaded. So I'll get a list of packages, and I'm extracting some package level information, like the version string, the architecture, is it x86 or AMD or whatever, and adding them to a UI list so that I can represent that data in the UI. And then when the user selects one of those items from that list, I will then cache that specific package. And what I'm going to do then is, well, once I've got that package, I can get diagnostics for that package. Remember, you can get diagnostics now for an app even before the app is running. If you know about the package information, you can get diagnostics for that app, even though the app is not necessarily running. And then subsequently, I can activate the app. So I'm using the package information. This is still building slowly. Oh, here we go. Okay, app coming up slowly. Let me just switch back to the code for a second. I'm going to get the package information and use that to get the app list entry. From the app list entry, I can then use launch async to actually activate the app. So you can see I kind of front load, get the package I'm interested in, get the app list entry, prepare my diagnostics objects, and before anything is running, and then run the app so that I can immediately start getting diagnostic information right from up front when the thing is running, as opposed to starting it running and then hooking in later. And then once it is running, I've got simple polling set up where I'm just updating the data every 2 seconds or so. So I'm updating the execution state, for example, and the pattern is the same for all of these. I'm saying, okay, get me from this target app, get me the resource groups, and then from the resource groups, get me the interesting data, like the state report, which tells me the execution state and the energy quota state. And I can get the memory usage. Again, same deal. I call get resource groups to get the resource groups and then iterate through them, because I could have multiple resource groups, and for each one I'm getting the memory report and keeping a running total of that. I'm getting the disk usage, and you'll see here that the disk usage and the CPU usage are in the process diagnostic info class. So once I've got my app diagnostic info object, I can get the resource groups. From the resource groups, each one, I can get a list of processes for that resource group. And again, typically there would be one resource group and probably one process, but there could be multiple resource groups, and each resource group could have more than one process involved. So for each one, I'm walking through getting the process information, the CPU information, the disk information, and the process-specific memory information, and so on. And a list of processes, a list of background tasks, if there are any. So let's look at the app itself. See if it's going to work today. I'm going to have to make it a little bit bigger. There we go. So the first thing I do is get packages. That will use the package manager APIs to get me a list of all of the installed packages on this machine. And there's a lot of stuff installed. The one I'm interested in, I know, is this one. I don't know if you remember from the slide, but it's 55BD5. That's the background audio app service app that I'm developing right now. So I'll select that one. That pulls out some additional package level information. Then I can get a diagnostic, so I can get a diagnostics object prepared for this before it's running. It throws up the user prompt, because again, this is the first time I've just built and run this tool. Obviously, it's a one-time only, so that won't get in the way in future. Current state is unknown because it's not running yet. But then I can activate the app using the app list entry. So this will actually run the app, and then obviously the state switches to running. And then you would go through and exercise the app. You run all of your test cases, do whatever it is that you would do to verify that the app's behaving as it should. And as I'm doing that, I can start polling for data. And right now, you can see that some of the information is not actually coming back correctly, and that's just because of the state of the current build that I'm on this machine. I'm not actually getting the correct CPU data and the correct disk data, and it also doesn't know the energy quota state yet, because we haven't built that piece in yet. But you can imagine these would be filled in with some valid time span information for the kernel and user time and number of bytes read and written and so on. And the memory data comes in, which, because it's app data, it means it includes both the private commit and the shared commit, and things like the app level and the app limit, if there is one, the list of background tasks, the list of process IDs, and so on. So you can imagine you could build out a kind of a profiling harness for your own app, and then run it through its paces. So just to summarize, use the new APIs. You can use them either for the case where you want to build a general purpose tool to monitor other apps, or to profile and debug your own apps, which I think is the more interesting use case. So you get additional information beyond what you can get from Visual Studio right now. But if you think about it, these are WinRT APIs, so you can build them into a UWP app if you want to, and you can ship that app in the store if you want to. Remember, there's an additional scrutiny because of the restricted capability. But you could ship them in a UWP app. If you're building your own app profiling tool, you're probably not going to put that in the store, so it doesn't really apply. But you could also build these into a Win32 app, which means that you could build it into a Visual Studio extension very easily, and into a Windows Device Portal plugin as well, very easily. So please get started now. We're fleshing out the APIs. There's more coming with each release. Join the Insiders program. There's documentation already for the Creators Edition of the API, but as I say, we're fleshing them out, which you'll get access to if you're in the Insiders program. And provide feedback. Tell us what's good, what's bad, what's missing. That's it. Thank you.